Hello. Can you hear me?
Yes, yes, yes.
Okay, just wanted to make sure.
Welcome back, dear participants. Yeah, now we have with us for the topic on time series analysis and forecasting, we have with us Mr. Srinivasa Raghavan. He is actually the Senior Principal Consultant at LTIMindtree, New Jersey. He is today with us to handle the 10th session of our ATAL FDP on the topic Foundations and Applications of Data Science. Mr. Raghavan, actually, he has 16 years of experience in the insurance domain, specializing in life and annuity clients. He has completed his Bachelor of Technology in Information Technology from the University of Madras, and later he has pursued his MBA in Insurance and Systems from ICFAI Business School. He is also a LOMA certified domain consultant. Over the years, he has successfully led the business consulting and the transformative initiatives, legacy modernization programs, digital strategy rollouts, and large-scale implementations for the leading insurers across the globe. He has a deep domain expertise across the insurance value chain, spanning the new business, underwriting, policy services, distribution, producer lifecycle, and claims management. He is also well known for facilitating the design thinking workshops, user group meetings, and process improvement initiatives, which bridges the business and technology. In addition, he holds multiple global certifications, including FLEMI, ASRI, Azure Fundamentals, and AWS AI Practitioner, reflecting his strong technical expertise in cloud and AI-driven solutions. Currently, at LTIMindtree, he continues to drive the innovation, thought leadership, and customer-centric solutions while building strong client partnership across the insurance sector. We are truly honored to have him with us today, and eagerly look forward for the insight and knowledge that he is going to share with us in today's session. Welcome, sir.
Thank you so much.
Yes, sir. You can continue.
I don't seem to be able to share my video. I don't know if it's access restriction, but
No, sir, you should be able to do it. Otherwise, you can send it across in WhatsApp to Dr. Weisley, sir. She can get it done from her end.
okay. No, I mean, when the camera option doesn't seem to be enabled, but that's fine. Let me see if I can sharing the screen seems to work. So I will.
Yes, sir. Yeah.
Go with that option.
It should work because other participants have handled the video sessions. It should be possible from your end also.
Sure. Give me 1 second here. I'm going to make sure. No, I think now, yeah. Once I started sharing the screen, looks like the video has come up. Hello, everybody. Thanks for making the time today. Are you able to see the screen that I'm sharing?
Yes, sir. It's visible. Yeah.
It's in the presentation mode, right?
Yeah.
Okay, great. All right, I'll get started here. Thank you, everyone, for joining. My name is Srinivasa Raghavan. Thanks for the warm introduction. I'll just probably add one more line to introduce myself right before I go forward. See, in my most recent role, um, I am chartered with leading the insurance strategy and advisory for emerging technology, right? And what does that mean? It means looking at new technology, its relevance for insurance company, how does it apply, right? What are the pros and cons? What are we seeing in the industry? What is the trend moving towards? And then trying to bring that insights back to the insurers so that they can proactively take steps to keep them up to date in this space, right? So as part of that, I constantly look at technologies like AI, machine learning, quantum technologies to see where they are progressing. So happy to bring all that experience and share with you. And like I said before, I want this to be a very interactive session. So feel free to stop me anywhere, go over the questions. I try to keep the agenda fluid. So let's take stock as we go forward, and then pivot based on where your interest is. Now, before I get into time series and the crux of it, right? I want you to see what you see in the slide, right? You see 4 images. You see a bird, right? An albatross that typically migrates thousands of miles, right? And it doesn't see land for years, is what they say. The second one you all know is Mr. Warren Buffett, a well-known investor, one of the very few guys who's actually been profitable in the stock market world, right? Third, I don't know how many of you are joining from Tamil Nadu and the Chennai region, but for the rest of the folks who've not seen this, if you're joining from somewhere else, this is one person who's probably loved and hated by a lot of children in Tamil Nadu, right? And it depends based on what he says. And he's a meteorologist. He predicts the monsoons and kind of the guy who gives guidance to whether the schools would stay open or not. So that is Mr. Ramanan. Last is an image of a GPS showing a map of when you would reach home. Right? Do you see anything in common in all of this? If anybody wants to unmute and share what it
Forecasting,
is.
sir.
Great.
Forecasting and prediction. Prediction and forecasting.
Very good point. Yeah. See, now all these 4 people are actively use the concept that we're going to talk about today, which is analyzing time series and forecasting, right? So good guess. So that's the reason I just put that is see how many different ways this gets used. Okay, good. So let's move forward. So what will we do so we've got around 80 minutes left now, right? Or maybe a little less, 70 minutes left. So we'll try to get an overview of what time series forecasting is, right? Where does it fit in the overall data science space, right? What makes it special and the most used technique? What are we seeing as the applicability of this, right? Now, the components that make this up, what are the type of forecasting models that we have, right? What is the emerging trends that we see in this space? How is Gen AI coming and disrupting the space? What are we seeing as the opportunities there? Right. And then we'll also try to wrap it up with some call to action on what you should be doing. Right. So we've got a lot to cover. And like I said, I have close to 20 years of experience in the insurance industry. So I'll try to bring all that experience in as I go through some of these topics and concepts. I'll also try to relate with some very simple real world examples so that you can understand and explain these concepts, right? And you get a grip of it. Right now, if you can walk out of this meeting saying, okay, I at least understand what these concepts are, right? And how does it relate? I think I would have won in my role today. So with that said, I am going to jump into the introduction. Right. Now, time series. See, let's start with what is time series first, right? So it's a sequence of data points that are collected, recorded, and measured at successive evenly spaced intervals. The key is these evenly spaced intervals, right? Now, each data point in that represents an observation or a measurement, right? It could be something that is measured over time, where the time is usually on the horizontal axis, right? Where we represent time on the horizontal axis, and the parameter that you want to evaluate, right? Which could be a variable of interest, like the sales, the effect of GDP, anything like that would be on your y-axis. Now, time series analysis is a technique that looks at historical data. Now, you plotted this data in a graph, right? So time series analysis is a statistic technique that looks at this historical data. It tries to identify what are the patterns, right? What are the trends that we see? Is it growing up? Is it going down, right? Are there seasonal reoccurrences that are happening? So it is all about identifying those trends and patterns in the data over different periods, right? Like, for example, why has the sale of a particular region gone up in the last 2 years, right? What is the impact of inflation that we're seeing in GDP? What is the impact of the tariffs on the Indian economy, right? Things like that. So it is about understanding the impact of the data, right? But it's still not about predicting the future, right? So time series analysis is about analyzing the current data. Finally comes time series forecasting, which is that branch of science which will look at this. It takes the data, understands the past patterns, and then tries to apply and predict the future, right? Will my employment rate goes up? Will it go up, right? When is the home interest rate coming down? So things like that, where you predict and see where it would be going, right, based on the data that you already have. So that's the introduction of what time series analysis and forecasting are, right? Now, with that said, before we go into any more concepts of time series, I want to spend like 5 to 10 minutes to understand why time series, right? Why should we even analyze time series data? What is its relevance for the global use cases, right? So that you can relate to the value that it brings, and then you can go and understand the actual concept itself. Now, see, usually they say a picture speaks 1,000 words, right? But in my opinion, if you take a properly well-graphed time series data analysis chart, it can speak 1,000 pictures, right? Time series can help you to uncover several insights. Now, to start with, let's say you can help monitor the performance of a parameter, right? You can track and find out if there are any particular patterns that you're seeing in the data, right? What is causing those patterns, right? What is the underlying factors that are causing this? What are the risk management approaches that might help mitigate these challenges that I'm seeing, right? And ultimately, like I said, finally, it is about taking it and predicting what could happen if this trend continues, right? Now, this is the whole decision spectrum. So if you really see, the decision spectrum typically starts with a what question. Okay, what is the problem, right? When did it occur? Why is this happening, right? And then eventually comes the how part of it. Say, okay, how can I solve this, or what would happen if I take this forward, right? So that entire spectrum of decision intelligence is something that can be answered through the concept of time series analysis and forecasting. Now, let's take a simple example, right? So I'm sure most of you have a pedometer or a smartwatch, right, to track your steps count. Now, if you have a time series analysis done on that data, which your watch or your app is already doing, right, it helps you to track how many steps you're taking on a daily path, right? It also identifies patterns to say, okay, the days on which you are doing more, the lazy days where you end up, doing your Sunday movie times, or if there are shopping days where you see the spikes in the counts, right? It helps you to track patterns. At the same time, it also can help you to find out if you're meeting your targets, right? You can set your goals and see how are you faring against the goals that you are. Now, what it currently does, I don't know, some of you might have seen, say, hey, you can still do it today. If you can take a 6 minutes walk, you'll still be able to meet your targets for the day, right? So that's a simple implementation of a time series analysis. I'm sorry, was there a question? Okay. Now, what is important is, according to Gartner, right, Gartner is the research firm, organizations that leverage this time series data gain in 2 ways. One, like I said, this is one of the most sought after analytical methods because of the accuracy that it brings to the table, right? So they gain close to 35% better accuracy when they use time series analysis. The second is they have an opportunity to reimagine their business from 3 perspectives, right? One, it can help you to reduce your operational cost by up to 25% of your top line growth, right? Now it can help you to improve your growth. At the same time, it can help you redefine experience. Now we'll see a lot of examples of what that means in the next slide. But I just wanted to say these are the three broad areas in which it can impact an organization. Now, I'm from the insurance industry. I cannot resist myself from relating back to that industry. Right? I just want to take one small example and tell you what I mean by that. Now, if you look at an insurance company's annual report, right, one of the biggest spend that they end up doing is the amount of claims that they pay, right, and the amount of which ultimately gets tracked under expenses. Now, expense ratio is the parameter that every insurer is evaluated against, right? The expense ratio is the amount of money that they spend for every dollar of money that they are earning as revenue. So 100, it's usually represented in the percentage. Anything 100 is you are spending as much as you're getting, right? Now, if your percentage is more than 100, that means you're spending more than what you're earning. Now, just a 1% of expense ratio reduction, right, can lead to multi-million dollars of savings, right? Now, how does that 1% or even 0.5% drop happens? It can happen with effective forecasting of how much claims you need to pay, where can you invest, right? So there's a lot of decisions that goes about in controlling that expense ratio. So that's why it is so important for us to understand this and see where it brings, right? Now, having said that, there are several areas in which time series is actively leveraged, right? Here are a few that you see, right? Banking, financial services, and insurance is a very heavy consumer of this concept, right? They use it for stock price prediction. They use it for market volatility analysis. I'm sure a lot of you here are into stock trading, right? At least if not intraday trading, at least you're a long-term investor. You might have mutual funds. So all those financial instruments work based on predicting what has happened on the stock price and then predicting the future, right? Similarly, if you look at the retail and e-commerce industry, they rely on this data heavily. Look at it from a seasonal prediction standpoint, right? The firms like your Amazons of the world, your Flipkarts of the world, trying to predict what that season is going to be, when is the Diwali season, when is the Navaratri season, how do I prepare myself, right? What are my supply chain arrangements that I need to take care so that you can be better prepared. Now, similarly, there is healthcare, manufacturing, environmental climate, where you have to look for the path of a cyclone, predict it so that you can make arrangements. All that relies on this concept, right? Now, what is important is the accuracy of this prediction, right? Now imagine a summer in Chennai, right, or for that matter, any city in the peak of summer, right, where your energy department has not estimated the demand, right, which ends up you having to have a 5 to 6 year of power shutdown, right? Or just imagine it'll be straight out of a movie of Hollywood where, let's say, you have a NASA is not able to predict where a space debris is going to fall, right? People are going to be, and usually, as if you look at those movies, it's always New York where it hits. So things like that, or even for that matter, like an event like Kumbh Mela that needs to be organized, right, which is the biggest human gathering with 66 crores. You have to be pretty much accurate. If not, there is going to be a severe impact. So that is why time series analysis provides you with those valuable insights and informed decisions that help you to make your decisions successful. I will stop there because I just wanted you to introduce you to the concept of time series before I move forward into the actual underlying components of time series itself. I'll stop here, see if there's any questions. If not, we'll move forward. Okay, I'll take that as a no. And I will move forward into the components of time series, right? Now, see, now that we know what time series is, right? Let's look at the 4 major components that you need to be aware of when it comes to time series analysis and forecasting, right? The first one that you need to understand is trend. So trend is a long-term movement of how that time series is evolving, right? Whether it's going upwards or is it going downwards or is it stable? Things like, price of petrol, gold never comes down, it always goes up, right? Seasonality, right? Seasonality is the second parameter, right? Which is about regular periodic occurrences that happens right now, but it happens in a smaller interval, which is less than a year, right? For example, it could be days, weeks, months, up to a year, right? For example, all your Christmas sales patterns, cyclonic seasons. These are all typical seasonality related concepts. The third one is cyclic patterns. People also call it as cyclicity, which are repeated fluctuations that happens, but it doesn't happen within a year, right? There is a little longer duration when these irregularities occur. Things like, a global recession, right? Things like the oil prices, which are in a way related to economy, they keep going in circles, right? You see the oil price goes up and comes down. I know it doesn't get reflected actually in Indian economy, but if you see in a global scale, there is always up and down of oil prices, right? Then finally comes the irregular patterns. Now, irregular patterns is everything else, right, which doesn't fit into these categories, where suddenly you see a spike, right? We sometimes it's also called as noise. Now, irregularities are like, let's say you have a war, you have a pandemic that hits you, there's a natural disaster. So things like that doesn't have a regular pattern, right? So those are called as noise. Now, knowing these concepts are important because addressing them in your models will be the key for driving your successful insight, right? Now, example, cyclical patterns and noise is crucial, right? Now, cyclical patterns are patterns that can be modeled for, right? So you need to look at it and you have to model after it. But noise is something that you have to remove from your data even before you model it out. So which is why it is important, right, for you to understand this. Now there are, so these are four concepts that I wanted to introduce you, because as you will go through the next few sections, you will see we will try to address some of these concepts. We'll try to see how do we eliminate noise and things like that. So I think it's good for you to understand this component before you move on. Okay. Now, let's get into the meat of the session today, right? Executing a time series analysis and forecasting project. Now, see, there are several different ways. One way is going very deep into these concepts, right? Going too technical into how you actually pick these algorithms. But I think I won't be able to do justice to just, one use case here. So what I thought I'll do is we'll take and understand the steps that happens, right? We'll try to understand what are the concepts and algorithms that are available so that you get a broader picture. But then the framework that I'm going to talk you to about will stay the same, right, irrespective of which route you take. So typically, there are three stages in a data science program, right? The first stage is called pre-processing or cleaning the data, right? Because data is the new oil, right? Your programs, your models, your algorithms are only as good as the data. You might be sitting on piles of data, right? But if they're not structured, if they have bias in it, you are only going to get garbage out, right? Garbage in, garbage out. So it is important that you first pre-process this data, clean it, right? Handle all those challenges that you might have in the data with respect to missing values, right? If there are outliers, how do you normalize those? Make sure you bring the data into the right clean format. Now, feature engineering might be required, right? Maybe you might have to add a few variables. You might have to bring some moving averages or volatility to reduce those, outliers that you're seeing. And ultimately, you have to split that data into your testing data set and your training data sets, right? And also visualize that data, right? So you have to do all this before you get into a model selection, right? The second step is where you go and select the model, right? You then again, you'll see the kind of models that you have in hand, right? And then you have to test those data sets with the data that you have, and then finally recalibrate and fine tune those models based on the initial results that you're seeing, right? Eventually, you'll go into a prediction and evaluation, which is about validating those model outputs on the unseen data, which is the test data that you have initially exclusively set up, and then evaluate the performance and fine tune it further as you move along, right? So because data science program is never set complete, right? You have to keep monitoring the drift, keep monitoring how the models are performing, how are they moving away, right, based on the new data that is coming in, and then try to recalibrate those models. So those are the three major steps, right? The first and the third step that you see here might be the same, right, irrespective of what data science program. It's not just time series analysis. You take a machine learning, you take a deep learning project, anything that you do, you will still find the same kind of concepts. But model selection and training is where you will see a lot of difference that are specific to time series, right? And we'll talk about that, what kind of models are available and the approaches there. Okay. Now, let's dive deep a little bit into, let me see how I'm doing on time. Okay, I think we're good. So data processing and exploration, right? So the first step is about, like I said, data processing and exploration, right? Now, if you see, there are outliers and missing data that you have, right? Imagine you're tracking your daily steps. Again, let's go back to the same example that we spoke earlier, right? There are some days where your phone battery dies, right? You might not have your phone, or you might not have your watch with you, right? And the app just records that you have 0 steps, right? Even though you walked. Now that's a missing value, right? Now, or maybe you ran a marathon, right, one day, and you got like 50,000 steps, which is way outside your usual range, right? Now that's an outlier. Now, if you don't fix these, right, our averages, our forecasts can get completely skewed, right? We can fill the, so what do? There are several approaches in which you can find these missing values, right? And you can detect them and remediate them, right? Both missing values as well as remediation. Now, what you're seeing over here on the screen are some of the tools that can be used for those processes, right? Now, second one is stationarity. Now, stationarity is a very, very important concept, right? Because most of the time series models that we will see today all assume that the data behaves consistently over time, right? But in reality, it is not, right? It's never. For example, your house prices, right? Let's say you take your house prices, usually they'll rise over the years, right? That's a trend. Now, if we apply this in the model directly, right, on that non-stationary data, the forecast will be misleading, right? The tests. So there are several tests that are available, like the ADF, the KPS, like the Phillips Peron. Now, these are tests that can help you to check how much of non-stationarity is there, right? And it can help you to transform and take that out so that you can bring that patterns and capture it consistently. Now there are several tests that you can apply on the same data set, right, to make sure you achieve that stationarity before you pass it on to the models for actually consumption. Now the third one is variance, right? Many series, if you see many data series, will have fluctuations, right? Now as this data grows, right, you will see that the value also grows. So let's take an example there. Take a stock price, for example. A $10 stock, right, might move just by 50 cents, right? But let's say you take $1,000 stock, right? It might swing by $50, right, based on the market conditions. Now, that bigger variance can cause and dominate the model and hide the real patterns, right? So which we don't want it, because then your model gets skewed to that the second scenario, and it would not consider the $10 stock price movement at all, right? When it comes up with the patterns or the forecasting. So again, there are algorithms that are available, right, to transform these variances. There is log transform, box plots, differencing. I'm sure you would have heard some of these in some of your other data science initiatives. These are the same algorithms and techniques that can be used, just that you're applying it from the context of time series here. Right. And the last one is the seasonal decomposition, right? See, now real world data often comes with seasonal patterns, like we just spoke about the electricity usage scenario, right? Summer, you will see a spike in AC usage, right? Winter, I know not so much in India, but in US, there's a very heavy usage of heating systems, right? So by decomposing these series into trends, seasonality, residual methods like SDL, we can see those hidden structures, right, clearly. So this not only improves your forecasting accuracy, but it also will help you to better explain what is really driving these numbers. Okay, so that's the key, and it's important for you to understand how and what you go about. Now, these are 4 of them that I mentioned. There are a few others that you can apply, but just thought these 4 will be important for you to understand what needs to be done even before you get into an execution. Now, let's talk about the model selection and training, right, which is the second step in the process. Now, see, the next step in the process is selecting the right model, right? Broadly, if you see, we have three categories of models to choose from. The first one is the classic statistical methods, right, which form the foundation of forecasting, right? Which is the basic ones, and you'll see a few examples. The second one is machine learning models, right, which brings flexibility, adaptability for more complex patterns, right? Now, if you don't have time as a parameter in your data, right, then, but you still want to do a time series analysis, then machine learning models are better adapted, right? And finally, deep learning models are what you are very commonly used, right? Which leverages neural networks to capture your high, nonlinear, and intricate relationship in the data. I know you already have a session, or if not, you're going to have a session on deep learning. So you will definitely see a lot of relations to what it is with respect to here, right? As you see these examples. Now, how much ever I do justice, explaining these three types of models and what they do is going to be impossible for me to do, right? So what I've done, I've tried to find a small video that gives you an overview of these three different types, right? What are these models, right? What are their pros and cons and when to use them? So let's look at that, and then we'll come back and continue to see, okay, what more do we have from a model selection and training standpoint. With that said, let me see if I can open my window. I'll open a browser. Just tell me once you see my screen.
Let's explore different methods for time series forecasting.
Okay. Let me know once you see my screen.
Yes, sir. Yes, sir.
You're able to see, right? Great. Okay. Great. And I hope the audio is coming out as well, right? Let me play it and then you should.
Let's explore different methods for time series forecasting.
Are you able to hear the audio?
Yes.
Yes, sir. Yes, sir.
Great. Okay. All right. Thank you so much.
Let's start with the most straightforward approach, statistical methods. Two common statistical techniques for capturing trends in time series forecasting is regression and ARIMA. Regression is useful for identifying steady trends, while ARIMA is effective for handling data with trends and seasonality. Both methods are valuable tools for understanding and predicting patterns over time. Our next forecasting method is machine learning. Unlike statistical techniques that handle data sequentially, many machine learning models treat time as just another feature, allowing us to create patterns from past observations without following the order of events. These are generally regression models, adapted and expanded to include more complex algorithms to identify relationships between variables. One useful model is support vector regression, or SVR. This is an adaptation of support vector machines and works by finding a best fit line within a margin, making it effective where data is noisy or nonlinear, like predicting sensor readings. Since SVR doesn't naturally account for time dependencies, the time can be represented differently. This approach allows SVR to capture complex patterns, though it may struggle with changes that happen over longer periods. Finally, let's explore deep learning methods, which excel at capturing the patterns in time series data. These models are really good with data that have long-term dependencies. One of the most popular models for time series forecasting is the long short-term memory, or LSTM network, which is designed to learn from sequences and capture long-term dependencies by selectively remembering and forgetting information. This makes LSTMs ideal for sensor data, where past readings can strongly influence future values. LSTMs usually require minimal data preparation, since they can identify trends, seasonality, and anomalies directly from the data, allowing for more nuanced forecasting without as much time up front. Another approach is the transformer model, which has gained popularity for handling time series data, especially when there are complex interactions over long sequences. Unlike LSTMs, transformers don't rely on sequential processing, which allows them to capture dependencies between any 2 points in the data. regardless of distance. Transformers are really useful when dealing with large data sets or when we need to understand interactions across multiple time steps. Knowing the common techniques in time series forecasting is great, but how do you know which one to choose? Choosing the right method depends on your data complexity, goals, and resources. But generally, for smaller data sets with trends or seasonality, statistical methods like regression and ARIMA are efficient, interpretable, and work well with limited computational resources. When time does not need to be sequentially represented for predictions, use machine learning models like SVR. These also tend to be more interpretable than deep learning models. For more complex or large data sets, deep learning models like LSTM and transformers capture intricate dependencies, but could require more processing power and larger data sets for training. And when your data has repeating cycles or sudden spikes, signal processing and wavelet methods can help to better understand noise or isolate specific frequencies. And if you're still not sure which method is right for you, try it all. MATLAB has apps for data processing, signal analysis, machine learning, deep learning, so you can try all of these methods quickly and see what makes sense for your project. For more resources and other videos like data preprocessing with MATLAB, check out the links in the description. Thanks for watching. I'll see you in the next video.
All right. So the reason I played that video is, you will get a perspective of the different types of models, right? What are the pros and cons of when to pick what, right? Now, you only saw a few models, right? That doesn't mean that those are the only options that are available, right? Now, if you see, there are several more. There's something called vector autoregression. There's something called state space models, right? There are tree-based models that are machine learning models. And then you have models like Facebook Prophet, which is more suitable for data sets with strong seasonal effect, right? So it is, and if you look at it from a deep learning standpoint, there is RNN, CNN. I'm sure you've heard about recurrent neural networks and convolutional neural networks, right? Now, they are more suitable for sequential data. So the key takeaway here is to evaluate these models, right? Understand what your use case is, right? Which models works better for your use case. Identify the best model that fits your requirement. And like it was said in the video, try a few, right? It's not always sure that it is this one model that will always work, right? You have to try multiple models to see how it behaves for the data that you have. And based on that, you can, iterate and pick the right model that works best for you. Now, before we move to the next topic, which is about evaluation itself, I just wanted to leave you with some thoughts on the technology front, right? So how do we implement this? Now, there are several software packages that are available. I'm sure all of you in your journey in this data science space is actively using these, right, to implement time series analysis and forecasting, right? You might have been exposed to R, Python, MATLAB, right? Several options are there. So even if you look at it, and there are several libraries that are available that you can pick up and consume for this, right? For example, if you look at it from, in the Python space, there are two major libraries, right? Pandas that can be used for importing and analyzing this time series data, right? And handling those missing values, all that pre-processing work that we talked about earlier, right? And actually performing the model soon itself, right? And then you have matplotlib, which can be used for data visualization, right? Now, you also saw in the video that they spoke about MATLAB as a platform where you can do this. So there are several ways to do it, right? And it's a very actively evolving space. So keep a lookout for what's the right technology. But I think what is more important is to look for the right models to pick from, right? Work on your data. The technology is always there. These days, the challenge is not, this is what I usually tell my customers, right? There used to be a time when people had a lot of ideas in their mind, right? But you were never able to, you never had the technology to support it 5 years back, 10 years back. With the evolution of the explosion of this data space, right, with all your data lakes, right, the amount of computational power that AI brings to the table, technology is now no more the challenge, right? You can always do anything. It's about what do you want to do, right? And how do you do it, which is the key that you have to focus on. So that is that. I will go over one more slide and then we'll stop and see if there are any questions, right? So the next one is about forecasting the accuracy, right? Now, evaluation in broader. So this is the third stage, right? After you have done your pre-processing and your model selection and actual implementation, right? You have to evaluate these models, right? Now, there are several measures to evaluate models. I've listed 4 of them over here, right? Your mean absolute error, your root mean square error, right? Your RMSE, as it's called. Then we have your mean absolute percentage error map, and then your MASE, right? Which is your mean absolute scale error. Now, these are all metrics, again, which are common across data science. Right? They're not exclusive to time series, right? And for that matter, even for that matter, forecasting. But they are especially popular in time series forecasting because they measure how close these predictions are to the actual observed values. So you will see that in time series analysis and forecasting, we use these metrics a lot to evaluate. Right now, if you take a look at the graph on the right hand side, right, you will actually see a comparative chart, right, of 4 popular error metrics, right? All the 4 that we just spoke about. Now, each of them is evaluated across 4 criteria. One is sensitivity to outliers, right? What is the scale independence that it brings? Is it interpretable easily, right? Or what is the interpretability of the outcome of this particular metric? And also the cross data set comparison, right? Now, in the interest of time, let's take one metric and try to see how, and let's try to break it down. Right? So now, mean absolute error is one of the most widely used metrics, right, in forecasting, because how easy it is to understand, right? That's what it really means, right? Now, look at the yellow bar, right? 95%, close to 95% is what is the interpretability of it. It tells us that the average absolute difference between the predicted and actual values, right? Which makes it very intuitive. Now, on the flip side, it has some limitations as well, right? Now, if you look at it, it is only moderately sensitive to outliers, right? I think it's about somewhere around 40%. I have the image on the right-hand side, so I'm looking to my right, right? Meaning it won't fully capture the impact of extreme errors, right? Which is something that we have to be cautious about. Now, that is where maybe MASE might work better, right? It also isn't strongly scale independent, right? Look at it, it's just 30% of scale independence. So comparing to MAE across data sets with different scale isn't ideal, right? So when it comes to using it across data sets, it scores only 35%, right? Which is again a limitation to take it and compare it against broad comparisons. Now, which is where something like, again, a MAP or a MACE will work better. So the key takeaway is MACE is great. Your mean average error is absolute error is great when you need a simple, easy to explain measure of forecast accuracy, right? But it's not the best choice when comparing models across different data sets or scales. So for such cross-border comparison, MACE works better. Now, no single metric is perfect for all your scenarios. So always consider using multiple metrics, right, when you're evaluating your forecast accuracy, and choose the metrics that aligns with your specific business objectives. Right? I know you already had a session on machine learning, so I'm assuming some of these concepts of metrics and evaluating the models would have been covered. So I'm not going to get into too much of depth here, but I will stop here and see if there are any questions on the execution of the project itself, because from here we are going to move into a slightly different route on what are the emerging patterns, right? Where are we seeing the use cases and insurance and things like that. So I'll pause here and see if there are any questions, and use the time to just take a sip of water. Okay, it's been a silent group. I know it is a Friday evening, so not the most exciting thing to do, sitting and hearing to a lecture. But bear with me for another 30 more minutes. I know I'm the guy standing in between you and your dinner. So I'll try to wrap this up in the next 20-25 minutes and give you some time to go and enjoy your dinner and the rest of the weekend. Right. So let's go into future trends. Right. Now, as we move to the last section, right, of this, maybe even before I open that slide up, right. Now, as we move to this last section, right, let's spend some time on what we are seeing, that what is emerging in the space, right? Now, you all have already seen the plethora of generative AI models that have come in, right? And the shift towards agentic AI in the last 6 months, right? Something that keeps me awake all night, every day as I meet customers, because, being in a consulting role, it is very, very difficult to keep pace with what is happening in the AI space, right? Because every insurance customer, I'm sure not just insurance customer, any customer is equally interested, right? They want to know, okay, what is happening? What is it going to be? Would this technology stay or would it go away, right? Is this the right time for me to invest in these models, right? Is this is it good for me to go and build these models, or should I go and buy these ready-made off-the-shelf solutions from platforms and COTS providers that are already built it? So there are several questions, right? So it's important for us to keep understanding this and making sure we give the right recommendations. Now, the reason I spoke about that is in the time series analysis space also, we are seeing a shift, right? We are seeing a shift in the series analysis from simply making single value forecast to using generative AI models, right? That can learn what the future could be, not just what it would probably be, right? So what these advanced foundation models bring to the, okay, what these bring to the table are richer forecasts, right? They are pre-trained, so they can work across different domains. Now, imagine you are a technology company and you have to go and talk to a manufacturing customer. At the same time, next day you have a finance customer, and then the third day you have to go and meet with a retail customer, right? You cannot be building models overnight, right? So these cross-trained, pre-trained models can help you to adapt to them much faster, right? You don't even have to train them. So that is the power, though, that these then generative AI-based models can bring, right? Now think of this as a difference between a weather forecast, right, that gives a one predicted temperature versus a model, right, generative AI model that can give you a a forecast where it says there's a 70% chance of rain, 20% chance that it could actually be a thunderstorm, not just a simple rain, and there is some chance, which maybe is like 20%, that it can just stay sunny, right? Now these richer forecasts are possible with generative AI models because they can process huge amounts of data, right? And the context prompt length of these models are just growing day by day, right? They can consume so much of input and they can give you outputs in quick succession. So it is important to understand what is happening in the space and keep track. Now, for example, I've listed down 4 models here, right? So these are generative AI models that are specifically built for time series analysis, right? So models like the Sundial and the TimeGen1, right? They are actually leading the race here, right? They are foundational style models that can generalize well across many domains, right? They can handle irregular or missing data, right? And at the same time, they can also produce probabilistic forecasts, right? Like it said, they can say, okay, this is the probability of something happening. It's not just saying what is happening, it's also telling you what is the probability of something that is happening, right? Now, the other ones that you see over here, like Timer Excel and ScoreCAD, are pushing the envelope in capturing global and local dependencies, right? Model uncertainty, dealing with multivariate complicated series. So that is where they are trying to operate. So they're trying to find a niche and try to see if they can focus in those spaces. Right now, of course, the table on the right is also giving you a comparison of where they are good and where they are better, at, right, compared to each other. Now, before I move forward, I want to do one more video for you, right, which is a quick video of how TimeGen1, which model, is, right? And how it compares against your classic statistical models and your deep learning models, right? So it's a quick 2 minutes video, but it will help you to understand. And I will share the link of the video as well after this meeting if you want to take a look at. There's actually a hour and a half video of the person, the CEO of Time Gen 1, Nixtla, actually explaining how that model works. It will be good for you to take a look at that. But this short video is good for you to just understand the comparison of it. Okay, just give me 1 second. Again, I'll have to probably switch screens and then present it. Just bear with me for 1 second.
Let's take a look at what's new and different.
Again, a quick logistics check. I hope you were able to see the screen as well as hear the video, audio. Can somebody confirm?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Oh,
Yes, sir.
great. Okay. All right. Okay. Let me go back.
Let's take a look at what's new and different in the Azure AI Model Catalog. So here we are in the Model Catalog in Azure AI Studio. As of this recording, there are now 1,786 models in this catalog. But every time you look, this number gets bigger because we add new models almost every day. One of the models in the model catalog is not like the other ones. This one is Nixtla TimeGen. It's a generative model, but it's not a language model. It uses generative techniques to do time series forecasting. I decided to do a little experiment with Nixtla TimeGen, and I made a notebook here in Fabric and connected it to a lakehouse. I wanted to see how the pre-trained TimeGen compares to traditional time series forecasting methods like ARIMA and Profit. This was a back test, so I had actuals to compare it to. Here's what I got with ARIMA. Here's what we see with Profit, a little closer to the mark. And here's what we see with TimeGen, significantly closer to the mark. I tried these both with the base TimeGen model and also with a version of the TimeGen model that I fine-tuned on this data set itself. And in the end, the numbers are clear. Both by mean absolute error and by root mean squared error, TimeGen comes out on top.
Great. So the reason I played that video is just to tell you the power that it brings. Right now, these are pre-trained models, so you really did not have to go through the challenge of building that model grounds up, which is a very, very heavy activity, right? That completely goes away. All that you can do is probably fine-tune the model, but it is much better to do that when it comes to. And now that's the pattern that we are seeing, right? So the effort of what you take in building that model goes away, which is where I was going back to the point that I was mentioning earlier with companies. And you'll definitely see that that's the perspective that again, I'll talk about it more when we conclude, but that's the kind of perspective that you are expected to bring, right? Okay, hey, is it right to build or is it right to buy, right? What is the advantage? Now, am I going to be locked in if I go and buy this time gen one, and then let's say 3 months later, there is another model that comes which does even better. So there is a lot of questions, challenge with all this evolving space, but at least it's good to understand where the space is evolving so that you understand and you see how you need to prepare yourself as you get into this domain. Right now, the last but not the least, right? These models has a drawback as well. Right now, they are very heavy in terms of infrastructure. Right, they can be harder to interpret and require careful evaluation. But see, like I said, there are pros and cons of going and doing it your build versus buy route. So it's always important for you to understand what would make sense, right? Whether is it more time that is the constraint for you to get to an output, which means a buy would be better going with a model like time gen 1, or if you think I have the time and there are some very niche set of data which might not work with the out of the box models because they are more generalist models, right? They're not very focused on a particular domain. They can work well for some broad use cases, but they won't go very deep. So that's the trade-off that you will have to make and decide the right model that works well for you. I will kind of, we are in the last 20 minutes, right? But before I go to the conclusion, I want to spend 10 minutes on something that is very close to my heart. Right now, you've seen the evolution of all these models. Now, how does this apply? Right? What are the possibilities? We spoke about individual use cases, examples throughout the session. Right now, what I've done is just to help you understand. I've tried to take these possibilities, right, and the opportunities that it brings from an insurance context, and I've tried to play it out for you. Right now, what you're seeing on the screen are actually, it is not just generic. These are time series based use cases across the insurance value chain. Right now, each pipe or each column that you see over here are focus areas within an insurance organization. Right now, strategy and product design is all about defining and designing the product. That, when I say product, these are the products that you will go and buy from an insurance company, right? Like your HDFC Click to Protect policy, right? Or your motor policy that you buy from ICICI Lombard, things like that, right? Then you have your sales and marketing value chain. Then you have underwriting, you have customer service, you have claims. Now, in each of this, if you see, there are several use cases that are right candidates where a time series model can come and help you, right? For example, profitability, product profitability analysis. See, insurance companies sells millions of products, right? They have to come up with what is the right premium. They have to determine what is the mortality and morbidity rates, which are the rate at which people live and die in a particular zone, right? It could be as small as a pin code, or it could be as big as a country or a region, right? So they have to look at that, predict those mortality rates, apply that on the product pricing, and come up with, will I still be profitable if I go and do, right? So that is one use case. Now, if you look at it from the sales and marketing standpoint, there are several use cases, right? Now, you all know insurance is a very advisor focused business, right? You have agents who go and sell these policies to customers, right? Performance of these people are tracked actively, right? Because they have to know how much sales they have made, how many policies they are bringing in. Is the number of policies that I'm bringing enough for me to get my commission? They are paid on a commission basis. So the more policies you sell and the more premiums that you get for it, you're going to get more, right? So actively trying to understand what has their performance been, where are they lacking, why are they not able to sell, identifying what are the patterns that we are seeing with respect to them not able to convert their leads, right, into customers. So these are all good candidates that you can look at and try to apply this in the time series context, right? Now, underwriting and claims, the third pillar and the fifth pillar, are, I would say, the core foundation of an insurance company, right? Now, underwriting, if you see, is the process of evaluating the risk of a particular application that has come in, right? You have to understand, okay, is this risk good enough for me? Right now, again, there is a lot of historical relevance for an underwriter, who's the person who actually decides to take that policy in, to see whether, okay, is the policy that is coming in, is it the right fit for me, right? How close is the 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 property or the factory that is being insured to a lake, right, which can lead to a water flood hazard, right? How much of fire accidents have happened in that particular address, right, for me to decide whether is there a fire risk? What is the nearest fire station? How much is the driving time, right? So all this is needed for you to know, okay, what is the chance of a loss that might occur, and an underwriter has to factor all this as they make decisions. Right now, if you don't have these time series models and you don't have the historical data, they will have to spend weeks, or they will have to reach out to a particular department for this data. And by the time they get this analysis, that customer would have shopped that policy with another insurance company, right? So it's about agility, being able to do this analysis faster, but at the same time, do it accurately, right? So which is why time series analysis and all these models are important. Now, as I speak, I actively work with several insurance companies across the world, right? Building some of these models, because these models are actively used for them in every value chain that you're seeing. For example, recently we did a claims use case, right, where there are loss exposures that they see, and they specifically had a challenge of subrogation, right? Subrogation is where when you receive a claim, you first pay the claimant that, okay, here's the money, but then you go and investigate whether is the problem because of the person who did this accident. Was the fault on my side, or was the fault on the other person who came and did it? In which case you have an ability to go and get the money from the other insurance company, right? So there was a specific model that we had built to find out the subrogation opportunity in a claim. So when a claim comes in, the claim adjuster, who's the person who's supposed to evaluate the claim, as soon as he sits down on the claim, they will be seeing a set of parameters to say, okay, what is the likelihood of this claim being a fraud, right? What is the likelihood of this claim, being subrogated, right? What is the chance that there might be a litigation on this claim? Somebody might come back and say, hey, I'm filing a lawsuit against this company, right? So there are several factors that needs to be kept in mind as you decide and arrive at these models. So those are the things that you have to keep in mind. Those are the kind of use cases. I thought it will be good for you to understand, because technology is one, right? But you have to have an understanding of the domain for you to be able to apply these use cases. Otherwise, you might have a great technology hat, but what problem are you solving? Unless you know what problem you're solving, there won't be any value in really, taking and adding value to an organization. So this, at least I'm assuming, I hope this helped you to understand the relevance of the concept of time series in an industry. Now you can go and do something like this in every single industry that we talked about earlier, right? And there might be several opportunities that might come out. So have a perspective, right? As you prepare, as you understand these technologies, have a perspective of how and what it relates to at least one industry. If not so many use cases, pick 3 or 4 examples of where you see this will help, right? And be ready with that point of view when you present this to a customer, or even for that matter, when you present this concept to your audience. So that kind of brings me to the last set. I want to, get into the conclusion, give you some takeaways, right? So what did we do? We kind of looked at what is time series. We analyzed what are its use cases. We tried to go into the steps in a time series execution. We also tried to see what are the what model works. We also try to understand the parameters and metrics that are used for evaluation, right? So there are 4 key takeaways I'll give you. One, it requires understanding of both statistical foundations and machine learning approaches, right? Because like you saw in that video, not every use case would need a statistical foundation model, right? There are scenarios when a machine learning model works better, right? And you saw the generative AI example also, where it is right to go and buy than build, right? So have that broader perspectives as you come up with your use cases, right? Focus a lot on pre-processing. It is much better, valuable, where you catch these challenges early on, right? Be it your outliers, be it your missing data, right? All your variants, handle all that before even you get into an actual model evaluation and execution, right? If not, you're going to be doing a lot of rework. Choose the models based on what your this one is. We spoke enough about it. And validations must respect the temporal ordering, right, to prevent data leakage. So last, I think we kind of talked about it multiple times. There are several different approaches, several different applications. So pick the right model that works the best for you, right? I've also listed some recommended resources that you can look at, right? The last one is actually a fantastic book, which is available for download for you to read time series and forecasting. Right? It's a very elaborate book, but it gets a lot more technical. So if you are into reading, I'll definitely suggest that book for you. That kind of brings me to the closure. Thank you once again for the opportunity to share my thoughts with you all. Right, it was indeed a pleasure to be here and present my perspectives on time series analysis and forecasting. Right, like I said, these are very, very exciting times, right? And it presents both an opportunity and a threat. It's an opportunity because, you catch this wave, the next 10 years is going to be all about AI, right? This is kind of the next industrial revolution, if not even bigger than that, right? But also at the same time, it's going to be a threat, right? Somebody who's not going to ride on this, we are going to lose out. So it's important for us to keep ourselves up to date, right? Stay relevant and be there. And thank you once again. I'm back to the organizer.
Yeah. On behalf of the St. Peter's College of Engineering and Technology, it's my pleasure to extend heartfelt thanks to Mr. Srinivasa Raghavan for having delivered such an insightful session on the time series analysis and forecasting. So actually, the topics were very explanatory, and especially the topic on the predictions with simple examples and the discussions that you have taken us through with clarity has brought us a clear understanding about the topic of forecasting and predictions. So your insight on the future trends in time series, the industrial applications, and the role of Gen AI models for the time series analysis has really given us a broader perspective on both the current practices and the future possibilities. So the way you have connected with the theory and the practical has also given us a great understanding and has also sparkled our interest in exploring the field further in the teaching and in the research areas. The videos that you have given us has also helped us to realize the power and the growth of technology in making an impactful and inspiring concept clarity. So I would really be grateful to thank you for the time and the effort that you have taken in sharing your knowledge for this FTP, sir. Thank you once again for your valuable contributions, Mr. Srinivasan. Yes, sir. Thank you, sir.
Thank you, and good luck. Good luck on all your encounters.
Thank you.
Thanks.
Thank you, sir. Thank you.
Thank you. Thank you.
So, dear participants, please be aware that tomorrow we are getting connected at 2 o'clock, 2 p.m. and the sessions will go on till 6:30 and links will be shared for all the individual sessions and you will have to take up a test, online test to take your certificates from ATAL and stay connected at 2 o'clock. Yeah, thank you. See you tomorrow.
Ma'am, today link?
Today link will be shared, sir. As usual, it will be shared here in this platform. Please stay connected for some time.
நீ நான் சொன்னது அடிச்சா இல்லையா நீ ஏன் சுந்தரத்தை